All right, let the party begin. We are going to talk about square roots today. So the square root of a number n, square root of n, is a number m, such that m squared equals n. I know that looks really crazy, so let's do a couple examples. The square root of 36 is 6, because 6 squared is 36. The square root of 9 is 3, because 3 squared is 9. And this symbol, it tells us to find the square root, but it's called the radical symbol. So if anyone ever refers to the radical symbol, we're talking about this. An important thing to keep in mind about square roots is that every positive number has two square roots, one positive and one negative. Because 6 squared is 36, negative 6 squared is also 36, because negative 6 times negative 6 is positive 36. So for every positive number, if we take the square root, there's a positive answer and a negative answer. How you'll know what the question is asking for? If there's nothing, just a radical symbol with a number, we're talking about the positive square root. So the square root of 100 is 10. 10 times 10 is 100. If I want the positive or negative square root of 100, it could be positive or negative 10. 10 times 10 is 100. Negative 10 times negative 10 is 100. If we put a negative sign out front, that means we want a negative sign for our answer. The only exception is 0. The square root of 0 is just 0. There's only one solution because there's no such thing as positive 0 or negative 0. Just 0. All right, so a perfect square is a number that's the square of an integer. So some perfect squares are 1, 4, 9, 16, 25, 36, 49. 1 is a perfect square because it's the square of an integer. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So these are my perfect squares. We can use perfect squares to help us approximate square roots. So what I mean is, let's say I ask you, square root of 20, no calculator. Well, it's not going to be a whole number, it's not an integer, so I'm kind of going to have to guess. So let's think about it. The perfect square underneath 20 is 16. 4 times 4 is 16. The one above it is 25. So the square root of 16 would be 4. The square root of 20 would be 5. So I know my answer is going to be somewhere in between 4 and 5. Maybe a little bit closer to 4, maybe about 4.4, because 16 is a little bit closer to 20 than 25 is. Let's try another one. Square root of 124. Let's see. 10 squared is 100. 11 squared is 121. So it looks like I'm going to start there. 12 squared is 144. So the square root of 144 is 12. So the square root of 124 is somewhere in between 11 and 12. And since it's pretty close to the square of 11, 121, it's probably much closer to 11 than it is to 12. Let's try one more. What's the approximate value of the square root of 51? Well, 49 is right below that. And the square root of 49 would be 7. So my next number is going to have to be 8. 8 squared would be 64. Square root of 64 is 8. 51 is a lot closer to 49. So the square root of 51 is in between 7 and 8, but it's a lot closer to 7. All right, so let's put it to practice. Radical expressions are expressions like these. We have to evaluate them, and they've got a radical symbol in them. The radical symbol is like parentheses. It's a grouping symbol, and it tells us do the stuff inside the radical sign first, and then take the square root. When we do our examples too, in a second, some things you need to keep in mind. The product property. If I'm taking the square root of a times b, it's the same thing as taking the square root of a times taking this, or multiplied by, the square root of b. So if I had this, square root of 9 times 7, that's the same as the square root of 9 times the square root of 7. Square root of 9 is 3. Here we are. The quotient property is if we're taking the square root of a divided by b. It's the same thing as the square root of a over the square root of b. So an example like this, square root of 11 over 4. Same thing as square root of 11 over square root of 4. Square root of 11, I can't really simplify it. It's going to be a decimal, so I'm going to leave it alone. Square root of 4 is easy. 4 is a perfect square. So square root of 4 is 2, and here's a simplified answer. So this was a lot of information. Let's put it into practice and do some problems. All right, square root of 180. I need to simplify that. 180 is a big number. It's got a lot of factors, so let me think. 18 times 10 is 180, but those are not perfect squares. 36 times 5 is 180, and 36 is actually a perfect square. So this is the same thing as this. I know from the product property that I could do this. And I know that this is a perfect square. Square root of 36 is 6. So my simplified answer is here. This is a lot easier to work with than this. Let's try another one. Square root of 24s squared. Well, I know that that's the same thing as the square root of 24 times the square root of s squared. 24, let's see, 8 times 3, those are not perfect squares. 12 times 2, no perfect squares. 6 times 4, 4 is a perfect square. So this is square root of 6, square root of 4, square root of s squared. Square root of 6, I can't really do anything with it, but the square root of 4 is 2. So now I'm here, and the square root of s squared is s. So if I were going to write this simplified, let me take these out. 2s times the square root of 6. Another one. I get to use my quotient property. So square root of 13 over square root of 36. 13 is totally not a perfect square, but 36 is. Square root of 36 is 6. So if I simplify it, voila. All right, another one. Square root of 54 times t squared. Let me separate out my constants from my variables. So 54, let me think. 27 times 2, not perfect squares, but 9 times 6 is 54, and 9 is a perfect square. So let me break this down into the square root of 9 times 6 times the square root of t squared. All right, product property. Square root of 9, square root of 6, square root of t squared. Square root of 9 is 3. Here, can't do anything. Square root of t squared is t. So let me just rewrite this. I hope you can see 3t square root of 6. Beautiful. All right, we've got another one. This one is a radical expression. I need to do some substitution so I can evaluate it. So we've got the square root of 48 minus 12. This is like a grouping symbol, so I need to do everything inside first. 48 minus 12 is 36. So now I'm here. The square root of 36, well, that's a perfect square. I know the answer is 6 because 6 times 6 is 36. And one more. I want the positive or negative square root of 49. Well, 49 is a perfect square, so I know my answer is going to be 7 because 7 times 7 is 49. But the problem wants positive or negative. So we could have positive 7. We could have negative 7. So I know that is a lot of information, but we will practice with it and we will become square root